We've been dealing with linear equations all along, straight lines, how to find them, how to graph them. But now comes the inequalities, if they're not equal. In other words, what does it look like if it's less than or equal to greater than or equal to or just greater than. Because up until now, we've only looked at these two. Not equal to. Now, why are they named as they're named? Why is this one less than? Why is this one greater than? Well, what do you need to have? In order for this to mean what it's supposed to mean, what do you need? Well, if I give you this, does that mean anything by itself? What do I need to make it mean something? I need values on both sides. This is what we call a binary operator, because you need two numbers. It's like plus, minus, divide, multiply, and equal sign. Those don't mean anything unless you have two numbers. One number's on both sides. They're called binary operators. And how do we read this? Yeah, read left to right. So how is this number connected to this number? It's less than. So basically you say that the arrow always points to the smaller one, or like how many people in elementary school learned alligator or the lion always goes for the bigger piece of meat. Any way you want to, as long as you remember it, that's great. Is this true? Yes. Why? Or equal to. There's this and this side could be equal. So that's what the symbols mean, which gives us an infinite number of answers. How do we write the solution for an inequality? So how do we write a solution to inequality? Right. There's one way you can write it. So we can write it that one number is less than another number. We can write it like that. Like that. We can graph it. Actually, what this really means is if we had this equation. 5 is less than x less than 7. Because what we're looking for are a series of numbers that satisfies our statement. A set of numbers. Which means we have 3 forms of our solution sets. One is called set notation. What is the set of numbers that satisfies this statement? Before mathematics became part of the STEM curriculum, think of back when mathematics first started. It was one of the first topics ever taught in when academics first started, in with Plato, Socrates, Aristotle, back then. Instead of mathematics, they called it logic. If you ever take a logic course, you're going to learn what's called modal logic, is if-then statements, which is the same way we teach mathematics should be taught. It's said by a lot of professors in universities saying that students, before they take the first math class, should take a logic class. And then you can start relating to what it all means. So set notation. Those are when you have these inequality symbols. What is the set of possible outcomes? The next set, we have the intervals notation. And these correspond to these symbols. Then we have the graphical representation, the graph of it. With our graphs, we could use the interval notation symbols, or more commonly, we use these to represent our points. Like, for example, if you have an open circle, that means it associates to the parenthesis, which means that you cannot include the number that it's situated. If it's got an equal sign, then we use it's the same as bracket, or on a graph, it's a solid dot, which means that number can be listed with the solution set. You have to know how to transpose between all 3 of these notations. Because I'll ask you a question, I'll say, okay, give it to me in the other 2 notation symbols, systems. That's what this worksheet is here. We'll go through these, and then once we finish this, you'll see exactly how easy the stuff really is. With a minor couple of rule changes. So you see the less than is the same as the parentheses, it's open circle. The greater than, parentheses, open circle. Less than equal to is bracket, close circle, greater than equal to. So the solid dot means it's equal to. It can be equal to. So I gave you the graphs. Those are the most easy ones that we're used to seeing. So what this is looking for What does this squiggly line represent? What axis is it on? X. It's a horizontal axis, so the x-axis. So this represents all x's that we can use. And this is called an infinite closed because it starts at a closed end and it goes on to infinity. The set notation, start with the lowest and then go to the highest. And where does it end? At infinity. So we start at A because A is less than the x's, which is less than infinity, and it could be equal to. So A is less than or equal to X. Now, a lot of people going through school, they were always told by their instructors, always put the X on the left-hand side. It doesn't matter because of commutativity. But if you want that, this can be written as X is greater than or equal to A. I'm going to start writing it this way because most of y'all have been taught or learned to put the X. And it makes it easier if X is on the left. Because if X is on the left, the arrow points to which side gets shaded. Well, yeah, because now my shaded region should go to the right of A. So that's what it tells us. We're going to the left of A now. So X is less than or equal to A. It shades in that area, so it's pointing to the left. The third one, now we have an open, infinite and open interval. So this is my X. So since X is to the right of A, we say that X is greater than A. Can it be equal to A? No, because it's an open circle. So it's strictly greater than A. And the next one, it goes from A to negative infinity. So X, since it's to the left of A, X is less than A. So these come in groups of four. So we did the first four. Now let's see how the interval notation looks like. The interval notation deals with brackets and parentheses, which means what? Unlike your set notation, each one of these, you'll have a beginning point and an ending point. So it goes A goes and to infinity. So you go to the smallest number and to the largest number in the set. Can you use A? Yes, so it's a bracket. Since it's a solid dot, we can use it. So it's a bracket. Can you ever get to infinity? No, so that's always a parenthesis. And the next one, reading left to right, we have negative infinity, and it goes to A. Infinity is always a parenthesis, and since A is a solid dot, it's a bracket. That's if we have the graph. If we have the inequality symbol, because the bottom of this inequality symbol is a flat line, so is this one. So that's the easiest way to remember those. The third one, look at the endpoints. It goes from A to infinity. And since A is open, it's parenthesis. And the last one is the smallest number is negative infinity, and it goes to A, open parenthesis, so it's open. Those are examples of infinite and open or closed. Those are infinite domains. Because it starts at a point, goes forever. The next four, these are now finite and closed. Finite means you have your x values are between two fixed numbers. Since it's in a bounded domain, we have to start. Okay, so where is x? With respect to a, x is greater than a, but it's less than b because x has to be between a and b. And they're both equals because they're solid dots. Here's the x there. So x is greater than a, but it's less than b. But a is solid, so I have a line underneath there. Here we go again. X is between here, so we have a is less than x, which is less than b. And this just simply goes on to the concept of anything to the left is smaller than anything to the right. And b is included, so it's a line underneath it. And the fourth one, we have a is less than x is less than b. And they're both not included. So what are the interval notations going to look like? You notice how in the set notations we have to have a relationship with x. But in interval notation, we simply have a relationship with the endpoints. So our endpoints are a to b. And they're both solid, so they're both brackets. The interval is from a to b. A is solid, b is open. A to b again. A is not included, so it's a parenthesis, and b is a bracket. Pretty easy so far. Now comes the lots of writing part. What this is infinite and closed, or infinite and open. The reason it's called infinite is because it goes opposite directions of each other. So these are my x's. They're at both ends. They're going infinity and negative infinity from those points. So we have two statements. On this side, it goes from negative infinity to a. So how do we write that in set notation? No. Well, yeah, we could do that, but since we're going to infinity, notice how we did it up here? We didn't put negative infinities. Yeah, x is not great. It's less than or equal to a. Or, because now it could be, if I give you an answer, it could be here or it could be here. So it's an or statement. Or x is greater than or equal to b. Not there. We only use the union symbol for the interval notations. So this one goes from parenthesis negative infinity to a bracket. And then on the other side, it's bracket b, comma, positive infinity. And we use the union symbol, which is the union symbol stands for or, because my answers can be here or here. It's both of those sets put together. Yes, always, because the brackets mean that you can get to that point. The parenthesis means that you'll never get to it. And it's like, if whatever number you give me for infinity, I'll just add one. For example, I mean, how many numbers are there between 0 and 1? Infinity. There's a theorem called Bolzano-Weierstrass theorem, says that if I give you two set points, finite number points, how many fractions are there between there? Any number you give me, I can divide it by 2. I can always keep on dividing it by 2. It'll never end. So that's why it's infinity. The next one, we have opposite directions, so we have two sets of answers. X is less than or equal to A, or X is strictly greater than B. We go from negative infinity to A, parenthesis, bracket, union, parenthesis B, because it's an open circle, and infinity is always open. Next one, we have X is less than A. It's open, so it's not equal to. Or X is greater than or equal to B. We have negative infinity to A, parenthesis, union, since it's solid, it's a bracket, B to infinity. X. Yeah, once you see the pattern of these, it gets very straightforwardly easy. So X is less than A, or X is greater than B. Again, what I said, remember, look at the arrows. If X is on your left-hand side, the arrows tell you which side is shaded. It's to the left of A, to the right of B. So now all of these are parentheses in this one. Those are the easy ones. Now this is where most people get mixed up. How would I do the next one? Yeah. X equals A. How would I do it as interval notation? Put your phone away. You don't need your trying to hide it behind his head. So now comes the set notation. Okay, and what it look like? You were close. Because remember, we're only using A, right? So we put A in brackets. Because remember, the brackets say use whatever's inside there. Since we only have one number, just put it in brackets. The next one, what it says here is it could be anything on both sides of A, but not at A. So this is X and this is X. How would we write that? Okay, so you're saying X is less than A or X is greater than B. That's not bad. Yeah, that works. Oh, yeah, I'm going greater than A. I'm sorry. Not, yeah, we don't have a B anymore. Right. That's not bad. Is there another way to write it easier? X doesn't, very good. X does not equal A. Very good. They're both the same thing, except if you're like me, like the less I write, the better it is. Since we used equals up here, might as well use not equals down there. But they mean the same thing. So what would your interval notation look like? Very good. A in parentheses. This simply means I cannot use A. I can use anything else, but I can't use A. But if you didn't want to use that, if you didn't see that, we could have done it the same way we did this one. Negative infinity to A, union A to infinity. We could have done that also. And the last one is all real numbers. It goes from that. X is everything. How do we write that? One symbol we can use is the R symbol. That stands for all real numbers right there. Now, how would we write it using set and interval notations? Well, interval, where is it going? What's the smallest, what's the largest? Very good, there. And for set notation, somebody said it earlier, just X. It's just X because there's no limitations now. Because once you use the inequalities and stuff like that, then you put boundaries on it. Just X by itself. Well, yeah, but you can use either one. But now, since we're dealing with X's and parentheses, this is another way you can write it. R is used for any type. So for example, on a question, I'm going to ask you, what's the domain of this function? There's on the very bottom of your screen, you can pick the R symbol, and that's the same as negative infinity, positive infinity, or. So those are. Oh, I forgot to real quick. Since you guys introduced to me this symbol, what's the other symbol other than, since U means or, what's the other one is and. This one stands for onion, union. It's another one of the fallacies of the English language. It's the same word, but all depends on how you pronounce the U. It means something totally different. And the N stands for what? Instead of union, it's what? I know it's or and, that's true. But instead of union, intersection. So this is a union of two or more sets. This is the intersection of two or more sets. In other words, the and symbol is only what they have in common. Again, this stuff was started thousands of years ago when we talked about logic. And is there any wonder when you're driving, you have your line here, your line there. What is this location called? It's called the intersection. Why is it the intersection? Yep, it's where this road intersects with this road. The same thing with number sets. But now, how does that relate to what we just did there? The union, if we had A or B, that could look like that. What this means is now only what they have in common. Right. The middle four. Because look what it says. It says A is less than X, which is less than B. Let's look what that means. Here's A. Let's do the equal ones. So what is the graph of this part going to look like? Yeah, it's going to start at A and then go this way forever. This graph goes the other way because X is less than it. We only want where they intersect. Which is why that's what it is. And this is the A and B. Still simple? Okie doke. Let's start solving things. Here's a couple of pointers. When solving inequalities, treat the inequality as an equal sign. Show you. Look at these. So in your sheet I gave you, we have example 1. Three x minus 5 is less than 6 minus 2x. The addition and multiplication properties are applicable here as well. It's addition property of inequalities, which says this. Well, the first one, we know that if this is true, then if I add a number to the left side, I have to do the same thing to the right side. Whatever you do to one side, you have to do the golden rule. So that's with equality. So if we had the inequality, if A is less than B, And if I add a number to the left side, I also have to add it to the right. And the inequality stays the same. Yep. It treated like an equation, but in the end, you know that it has to be a less than symbol. So if we change this to an equal sign, how do we solve this one? Yeah, so if we have x's on both sides, move the smaller to the larger. Add 2x to both sides. 3 plus 2 is 5x minus 5 is less than 6, because those cancel. Again, the addition property is still, whatever you do to the left side, you gotta do to the right. Now I have to get rid of the what? The 5. Get rid of the 5 by adding 5 to both sides. So 5x is less than 11. Last step, divide by 5. So x is less than 11/5. It'll accept improper fractions, even though in the real world of math, it's not acceptable. So we would change this to 2 1/5. Okay, what notation is this? Set notation. So convert it into interval and graph it. When converting between notation systems, it is easier if you graph it first. Because a picture is worth 1,000 words. It'll give you a better idea what's going on. And besides, you have to graph it eventually anyway. So, graphing this one. I label my negative infinity and my positive infinities. I have only 1 point. That's at 11/5. Is it an open or closed circle? It's open because there's no line. Which direction is shaded, left or right? Because it's pointing to the left. And x is less than. So now, going to the interval notation, we look at the lowest and the highest number of that squiggly place. It goes from negative infinity, comma, 11/5. Infinity is always a parenthesis, and since that's open, so far so good. Let's look at B. We're gonna do B 2 different ways. And you'll see that we'll get the same answer. We got 13 minus 7x is greater than or equal to 10x minus 4. 13 minus 7x is greater than equal to 10x minus 4. I'm doing this to show you that there's really no wrong way to start these things. Is that whenever you're solving for x's and you have x on both sides, always move the x's first. Never move the numbers first and then worry about the x's. So what would you do in the first one? Yeah, so we'll get rid of that one. So we're going to move the 7x, we're going to move the smaller to the larger. We're going to add 7x to both sides. 7x minus 7x is less than 11/5. 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 7x minus 7x 13 is greater than equal to 10 plus 7 is 17x minus 4. Since we have x on this side, we have to get rid of non-x's. How do we get rid of negative 4? Add 4 to both sides. So those cancel. 13 plus 4 is 17 equals, it's greater than or equal to 17x. Then divide both sides by 17. That's not a wrong answer. It's a perfectly acceptable answer. Except it looks weird. A lot of people want to see the x on the left-hand side. Just, yeah, like if you had your paper, just take your paper and flip it over. What you would have is x. It's got a point to the x. So 1 being greater than equal to x is the same thing as x being less than 1. So how would we graph this one? Right. It means the same thing here. If 1 is greater than x, that means x has to be to the left of it, has to be less than x. And in the interval notation, take your endpoints. Parenthesis, this is a parenthesis or bracket. And there you have it. All right, so that's doing the way we talk about. But a lot of teachers tell their students always move the x's to the left side because they want to get to this point here. So let's move our x's to the left side. Subtract 10x from both sides. They're both negative, so the answer is negative. Add the numbers. 10 plus 7 is 17, so it's minus 17x. Get rid of the 10, so we have negative 4. We have x's there, so we get rid of the 13. Subtract 13 from both sides. They're both negative, so we add the numbers. Now, unlike equal signs, whenever you change the sign of the variable, you have to change the direction of the inequality. Why? Well, let's go ahead and do that, and I'll show you why in a second. So, whenever you, remember I told you, whenever you have a negative in front of the x, change everything. Change everything. So it goes positive 17. From greater than, it becomes less than, equal to, and then it becomes a positive 17. And then we divide by 17. And here's the reason why. It is a shortcut. So if we had negative 17x is greater than equal to negative 17, algebraically, if we were moving things around, we have a negative 17. So if we add 17x to both sides, negative 17 plus 17 gives us 0. We have negative 17 plus 17x. Then we add the 17 because it's not an x. So it has to go to the other side. And then we divide by 17. So we have 1 is greater than equal to x. So instead of moving the numbers around like we're supposed to, we could just change the sign and change the inequality direction. That's the reason why. Because you're changing. If negative x is bigger than 5, that means it's the opposite of it. Then x has to be less than negative 5. What does that mean? Or on a number line. If x is less than 5, fold it at 0, which would give us negative 5. That means x has to be bigger than 5. We're getting the opposite of it. All right, let's look at example 2. It says, find the domain of the function. Again, I don't know why they throw this in here because it has to do, but we haven't talked about these functions yet. So we're looking for the domain. What do we know about radicals? Right. The only rule we have about radicals is inside there, it can never be negative. So what's the smallest it can become? 0. Square root of 0 is 0. So what we do whenever you have radicals, you want to find out what the domain is, take the inside of there and set it equal to 0. So this is the smallest or largest number that it gives me 0. Now, we can either go to the right of 6 or we can go to the left of 6. If we put 5 in there, what happens? We have negative, so we can't use that. If we put a 7, 8, 9, or whatever, then it works. So our domain is x has to be greater than or equal to 6. Or it goes from 6 to infinity. All right, that's A. How about B? Now we have 2 sets of rules. On B, we have a rational expression with a radical on the bottom. So first off, what's the rule about radicals? They can't be negative. So the smallest they can become is 0. But what's the rule about fractions? You cannot have 0 at the bottom. So we take the bottom number, set it equal to 0. We know that if x equals 3, we get a 0 on the bottom. So we can't use that. But in our solution set, we can begin at 3. We just can't use it. Now, do we go to the left of it? Or do we go to the left of it? Or do we go to the right of it? So take a number to the left of it, plug it in there. 3 minus 2 is 1. So that one works. Can it be 4? 3 minus 4? No. So I know my answers here go to negative infinity. So my x is going to be strictly less than 3, or goes from negative infinity to 3 in the parentheses, or that graph. And again, treat it the same way we do an equal. Here are just asking us what x's can we use. So once you understand, and we'll do this on Tuesday of next week. Before we do anything in the next chapter, we're gonna go over the library of functions. We're gonna learn all about the domains and ranges of these things because we're being inundated with it. We just have to know what the rules are, radicals and fractions and everything. Compound inequalities. This is when you have two or more inequalities in the same equation. It's usually called a tripartite. And the best way to explain this is by doing the example. A tripartite means you have 3 parts. Negative 3 is less than 2x plus 5 is less than equal to 7. Yes, it's like it's going to be those middle 8 actually, because we'll see what happens if x changes signs. So what this one says, you're right. We have an endpoint and another endpoint. So it'll look something like this. We have a number there and number there. X's will be in between there. So this is A and that's B. What are we solving for? X. So whatever we do in the middle, that's the only thing we have to look at. Whatever we do there, we got to do it to the outer two. Because think about it. We actually have 2 equations here. We have this equation, and then we have this equation. We're just doing 2 of them at the same time. Yeah, remember when I showed you this? If this symbol here is less than B, greater than A, we have 2 separate equations, we just overlap them. That's what's happening here. Well, you do it over the same space. So, for example, what is solving for x? What do we have to get rid of? The 5. So we subtract 5 from here and from here. Negative, there's both negatives, so we add the numbers. 8x less than equal to 7 minus 5 is 2. Divide by 8, so we divide 8 across the entire equation. Look, a blimp. Good question. It's that new math stuff. Inflation. So divide by 2 to get rid of the coefficient. So negative 8 divided by 2 is negative 4, is less than x, is less than 1. Okay. It costs extra, so. So yeah, when we have a tripartite, three parts, just work the middle one, whatever you do to it, just copy on both sides. But so what this means, remember, if it's in between two numbers like this one is -4 and 1. That's what that one looks like. What would the interval notation look like? Yeah, look at the endpoints. Look at the endpoints here. So it's -4, 1. Is that's an open parenthesis? This is a bracket. Okay, as I said, because this is two equations in one, it's this equation and this equation, we call it conjunctive. Again, it's a term they use in logic or conjunction. What's a conjunction? Think of your English class. Conjunction. Well, give me an example of a conjunction in English. What's that? I've. What does I've mean? I have. Conjunction is combine the two. That's what's happening here. I'm combining this equation and this equation. The opposite of that is disjunction, which instead of going between the two, they go opposite directions, which is again, it's the middle eight that we have. But before we do that, I'm going to show you what if we had this. -5 less than equal to 3 minus 4x. Let's say 9. So first step is what? Yeah, says look at the middle part. That's where the x is. So we have to get rid of the 3. So we subtract 3 from everybody. We have -8 is less than equal to -4x. 9 minus 3 is 6. Remember, treat the signs and numbers. So we have to change the negative. When we change the negatives, we got to change everything across the equation. Change the coefficients, change the signs, change the inequalities. So this one becomes +8. This one becomes greater than equal to +4x is greater than -6. You know what yeah, you don't want the coefficient to be negative. Because you have to work your way down. We got rid of the addition subtraction first. Now we get rid of the coefficient, the negative. Now we get rid of the 4. So we divide everybody by 4. We have 2 is greater than x is greater than -3/2. This is not the right order because we read left to right, it's backwards. So we got to flip the whole thing. We have -3/2. It points at it and it points at the x. So how would we graph this one? We have -3/2 to 2. X is between there. And I click that. So our interval notation would be parenthesis -3/2, comma 2 bracket. All right, let's look at a disjunctive, which they go opposite directions. Example 4. Solve this. We have 2x minus 5 is less than equal to -7, or we have 2x minus 5 is greater than 1. First step, you notice how this and this are the same equation. It just goes opposite directions. So what do we do first? Yeah, add 5. Add 5 across the entire equation. So we have 2x is less than equal to -2. Since 7 is bigger than 5, it's negative. Or 2x is greater than 6. Then divide everybody by 2, because we want the x by itself. X is less than equal to -1, or x is greater than 3. Remember, always graph it first. It makes it easier to look at. So is it open or closed circle on -1? Open or closed on 3? Right. Because there's a line here, no line there. X is to the left of it. So it goes to -infinity. And it goes to the right, because x is bigger than 3. So if x is to your left-hand side, just follow the direction of the arrow that tells you what side to shade. Shade to the right, this one shaded to the left. So this one goes from -infinity to -1, bracket, 3 to infinity, and they're both with a union in the middle. So far, so good. Let's look at an application, a word problem. I know, it's what you guys live for. Here it is. Income plans. For her interior decorating job, Natalia can be paid in one of 2 ways. Plan A is $250 plus 10 hours of work. Plan B is $20 per hour. Suppose that her job takes n hours. For which value of n is Plan B better for Natalia? So let's see how we build that. Example 5. Plan A says 250 plus $10 per hour. Plan B says $20 per hour. Which one's better? How do we do it? Where n equals number of hours. So how do we do it? How do we set it up first? Let's hold on there. Okay, yeah. For which plan, which n is B better? So in other words, which one would would plan B? So which plan would give us more money? Does B get more money than A? In other words, what this says, A is less than B. What you could do is set them equal to each other first and see at what point they break even. And then see which one is better with one more number added to it. That's one way you can do it. Let's look at it this way. For what number n hours is B better? So what's the equation for A? 250 plus 10n. Yeah, but yes, yeah, it's is less than 20n, where n number is number of hours. So if we subtract 10n from both sides, we get 250 is less than n, divide by 10. Those zeros cancel, so we have 25 is less than n. So for any n greater than 25 hours, it's saying that B is better. Is that true? So let's try n equals 30. Well, let's try 30. Plan A at 30 gives us 250 plus 10 times 30. 250 plus 300 equals 550. B at 30 is $20 times 30 is 600. So it works. So what would happen at 25? Yeah. Which is what I'm saying, is if you set A equals to B, you would find the breaking point. And then any more than that would be B side. So if A at 25, we get 250 plus 10 times 25, which is 250 plus 250 is 500. B at 25 is $20 times 25 is 500. So 25 is the breaking point. So now any number bigger than that or less than it will tell you who's better. So she has to get a job that pays for 25 hours or more to be worth it. And that's exactly how they do in business. They look at the job, say, it should take me about 10 hours, 12 hours to do this. So I'm charged you with this method. Oh, that's it for chapter 1.